In this video, I'm going to give a quick demonstration of the assignment pre-check program. This program performs various types of checks and tests on an assignment submission. So for the purposes of this demonstration, I'm going to use a Git repository that I already have set up. In the context of the course, when you're using this tool that I'm going to be demonstrating, the thing that I'm using a shell variable for, this remote repo variable, you would replace this essentially, the value of this variable substituted, you'd replace this with the URL on GitHub of your Git repository. So you can imagine that this is some GitHub URL that's specified here that I've highlighted. So I clone my repository and I've done some work on the assignment. Basically, I'll change to the directory that contains this assignment. This is just a toy assignment that's set up. It's not part of the course. It's just a very trivial assignment, just for illustration purposes. So the first thing I'm going to do is take a quick look at the files that we have here. So I'll just use VI to open these files. So the identification.txt file, which is what we're looking at now, this contains identification information for the submitter of the assignment, so like the student's name, their student ID, their email address, the course that they're in, the section that they're in, the term that they're currently in, and then also very importantly the assignment that is actually being submitted. The tools need to know what assignment is being submitted, otherwise they don't know how to process the submission. So this is the assignment submission. It's really important to include the assignment name and get it correct. If we go on to the source code file, this is not really a very exciting C++ program, but basically what it does is it reads words from standard input and then checks to see whether the word is a palindrome, and if it is, it prints palindrome, otherwise it prints not palindrome, and it just keeps looping. If we look at the CMake list file, there's not really anything particularly noteworthy about it. It's just your regular run-of-the-mill CMake list file. So at this point, I'm going to invoke the assignment pre-check command. This is the one that I'm demoing in this demo. Assignment pre-check, if I run it with no options, it just prints out help information. It's fairly verbose. It gives detailed information about the usage of this program. Anyway, the normal usage would be you give it a URL of a Git repository. Normally this will be your Git repository on GitHub, the one that you're using for GitHub Classroom to store your assignment submission. So in this case, you can just imagine that this substituted variable here is replaced by your GitHub repository URL for GitHub. Anyway, so I run this, and what it's going to do is it's going to pull the assignment submission from the Git repository by cloning it, and then it's going to do some checks essentially. It prints out some information about the submitter of the assignment and the assignment that's been submitted and so on. It gives the commit ID in the repository that is actually being tested, so that you know this might be a helpful thing to know. This here is the actual URL of the Git repository that I'm using. It's just local on my machine. The first thing that's actually done, kind of interesting thing that assignment pre-check is doing, is it's printing out validation successful. The very first thing it does is perform what I call a validation check, which is just making sure that the assignment submission basically looks sane. The file names are more or less what's being expected, and there's an identification.txt file included, so there's some, and it's formatted reasonably so that it's actually possible to tell who's submitting the assignment and which assignment is being submitted and so on. And then the next thing that it does, that this tool does, is it generates what are called packages. Packages are just transformed versions of the assignment submission. In the most trivial case, there's no transformation actually applied at all. In other words, the package that's generated is just identical to the assignment submission. And this is the case here because this is a relatively simple assignment. So this package that's called original is basically just a verbatim copy of the assignment submission from the student. The code hasn't been changed in any way, the build files haven't been changed in any way, and so on. And then once the packages have been generated, in this case there's only one of them called original, it then proceeds to configure and build. So it configures the code in that package, which is performing basically the configure stage of CMake. Then it performs a build, which is basically performing the build stage of CMake. In this case, the particular target that we're building is called is_palindrome. This is the actual executable program that's produced by this code. And you'll notice over in the status column here, it's saying OK for all of these entries, which is basically indicating that nothing's gone wrong. It was able to successfully generate the package, configure it, build it. And the things in brackets here, these are just the times that it took for each of these steps to proceed, measured in seconds. So everything went okay, and this is good, but also sometimes things can go wrong because maybe there's something wrong with your assignment. So what I'm going to do at this point is just induce various failure modes. So the first thing I'm going to do is go in and butcher the CMake list file, so things are not going to successfully build. So I'll just add some garbage here to the end of the CMake list file. And then I'm just going to commit these changes, push them back to my repository. Don't ever use git commit in the way I'm using here. This -m option is evil. If you have commit log messages that you can fit on a single line, you're not using git right. But for the purposes of this demo, I don't really want to type in a really long, commit message. So I'm just using the command line to do this. So I've committed those changes, pushed them to my repository, and now I'm going to try running precheck again. So I'm just using a similar command as before. Again, this $remote repo is actually going to be your Git repository URL for GitHub Classroom. In this case, when I run things, what we'd expect to happen is the configure is going to fail because I butchered the CMake list file, so when CMake tries to do a configure, it's probably going to die. And this is exactly what happens here. You can see that the configure fails. And of course, if the configure fails, there's no hope for the build being successful because you don't even have native build files that you can build from. You'll notice here that in addition to the time, there's some other information that's given. When it fails, the first number here is the exit status of the program that failed. Maybe the more helpful thing to you is the number that's given here. The L stands for lines. This is indicating that there's a log file with 7 lines in it that's indicating the reason, giving some indication essentially of what went wrong. When the various different commands are run to like configure and build and so on, and these various different operations that are performed, the output is captured into a log file. Normally you don't see that, but in the case that it fails, those log files are kept. But we can't see them from the way that we're invoking assignment precheck here. But what we can do instead is we can invoke it with an extra option, which is what I'm going to do next. So we're going to invoke assignment precheck with the -r option. And the -r option takes an argument, which is just a name for some file, particularly a file that's going to be output that's in PDF format. And what happens is when we run precheck this time, it goes through all the same steps as before, but it will also generate a PDF report file using the file name that we've specified. So I'll just run this through, and things of course fail the way they did before because I didn't change anything. But what's different now is if I look in this directory, there's a file called report.pdf. So I can edit this file and try to get some better idea of what exactly went wrong. Maybe I should back up to the beginning of the file here. So at the beginning of the report, it has like summary information that gives basically a similar output as what you saw in the more condensed form on the terminal screen a minute ago. But in addition, it gives more detailed information as well. So in this case, because the configure step failed, it actually includes in this report the output that was generated when it failed. And basically it's just telling me that the CMake list file is not valid, which is not surprising because I typed garbage into it. And also the build failed as well, but this is less interesting because of course the build failed if the configure failed. Anyway, so that's sort of generally what the report looks like. And maybe I'll inject some additional kind of bugs here. So I'll put the CMake list file back the way it was before, just so that that doesn't mess things up. And instead what I'm going to do is I'm going to mess up the C++ source code file that's associated with this particular example. So let's edit is palindrome. And I'm just going to type some garbage at the end of the file just so that it's not going to compile successfully. And then just like before, I'm going to commit the changes, push them back to my repository, because when you run assignment precheck, it's running it on your remote repository, so you have to push the changes to the repository in order to be able to run assignment precheck on them. So I push them back. Now I can run assignment precheck again. And in this case, what we'd expect would happen is that the compile is going to fail. So this is exactly what happens here. Generate is successful, the configure is successful because there's nothing wrong with the CMake list file, but when we go to build the code, the compiler is going to fail because the C++ source code file is not valid. So it fails, not surprisingly, and it mentions that, by the way, there's a log file that has 10 lines in it of potentially useful output to figure out what went wrong. So because I ran the assignment pre-check with the -R option, I generated a report file that I can look at. So let me just bring this back up here. So events, I'll run my PDF viewer, and in this case, well, maybe I should back up to the beginning of the file here. So it has basically the usual summary output as before, but in this case it has a log that's generated by the compile, and you can see here it's complaining it doesn't know what this garbage is that I typed into the source code file. Maybe as one last thing that we can do, well, I guess I can put this back the way it was before, so I'll put the source code file back as it was. And what I'm going to do now is I'm going to do a very kind of brutal sort of mistake. I'm going to remove the identification.txt file, and then I'll commit these changes and push them back to my repository. And then I'll run the pre-check again on this. And in this particular case, you're going to get like a very bad failure. It just like it outright fails. It can't do anything. It just says there's no identification.txt file. And because of this, because the identification.txt file is the file that identifies what the assignment is, because it's not there, it can't even figure out what assignment it is that you want it to process. Therefore, it can't do anything because unless it knows which assignment it's processing, it has no idea what to do. So this is failing outright. So this is basically the whole assignment has failed to validate correctly. So if you submitted an assignment like that where it fails in this way, you get 0 for the assignment because there's no way to mark it. The TA basically gets an empty mark report because basically what the TA gets to help assist in grading is a similar copy or a similar report as what I showed in the examples, the report.pdf, which includes the status of whether tests passed and failed and so on. The only difference being they get a much more detailed report with all of my test cases, which you don't have access to. So it's really, really important that you make sure that at least it's able to figure out what assignment it is and do some basic processing, but even still, you'd want to make sure that all the checks that it does perform that you have access to, that they all pass. If they don't, that's probably an indication I won't be able to run your code, and if I can't run it, I assume it fails. Like if I can't run a test case, it's assumed to fail the test case. If I can't build your code at all, it can't test any of the test cases, and all the test cases are assumed to fail, and your mark will reflect that. So make sure that your code is basically saying that you submit and it passed the checks that are actually performed by assignment pre-check that you have access to. And I think that's basically everything that I wanted to cover. So again, a brief introduction to assignment pre-check.